PSY213 class, this is lecture 13, forgetting. And forgetting, obviously we're talking about once you have something in long-term memory and you go to retrieve it and it's not there, you forget. This, sorry about that. This begins with a discussion or introduction to Ebbinghaus. And Ebbinghaus, what he did is he learned, or he created and learned, some what he called consonant vowel consonant trigrams. So you take like a consonant like D, a vowel like A, and a consonant like X, and you create this DAX, consonant vowel consonant trigram. So he created all these kinds of things. He studied them. He studied them till he learned lists of them to perfect criterion. That is, he could remember all of them. So it was definitely in his memory. And then what he did is he tested his memory for these consonant vowel consonants over time and generated what's called the forgetting curve. So you can see here what's called the forgetting curve. This is a typical forgetting curve where you lose a vast majority of information within a few days. You lose the vast majority of information that you've learned, but then at some point it sort of plateaus. Now these forgetting curves have been generated for all kinds of material. The slope can differ a little bit. The plateau will change depending on various factors, but the bottom line is the message that we learned from Ebbinghaus is that you forget a lot of information within a short period of time. Now you can, if you want to stave off this forgetting curve, what you can do is you can raise the plateau here. You can make it go higher and higher, but that takes more and more learning attempts, more and more exposures to the material, and you'll remember more and more information. But basically the forgetting rate doesn't really change. You're still going to lose a lot of information within the first few days of learning some material. So the question is, that's what happens. But why does this happen, right? It can be frustrating. A lot of times you think about forgetting as being very frustrating. Like, where did I put my car keys? Or why can't I remember everything I read for an exam that I have coming up? So most of the time we focus on forgetting as being negative, but the reality is it's probably really positive, or really forgetting exists to help us adapt. So one point I want to get across about this is remember some of the things that we've come across before, like an autobiographical memory. We talked about the people with highly superior autobiographical memory, or HSAM. Well, there was one person who has HSAM, and she didn't want to be a part of the 60 Minutes episode because she has a different experience with her highly superior autobiographical memory. Her name is patient AJ. And let me just read a little description from another article about how AJ describes her condition, and I think you'll see a theme emerging. Remembering everything is both maddening and lonely for AJ. I remember the good, which is very comforting, but I also remember the bad, and every bad choice, she says. And I really don't give myself a break. There are all these forks in the road, moments you have to make a choice, and then it's 10 years later and I'm still beating myself up over them. I don't forgive myself for a lot of things. Your memory is the way it is to protect you. I feel like it just hasn't protected me. I would love, just for 5 minutes, to be a simple person and I have all this stuff in my head. Most people have called what I have a gift, AJ says, but I call it a burden. Now the author sort of writes here, the whole point of our nervous system, from the sensory organs that feed information into the massive glob of neurons that interpret it, is to develop a sense of what is happening in the present and what is about to happen in the future, so that we can respond in the best possible way. Our brains are fundamentally prediction machines, and to work they have to find order in the chaos of possible memories. Most of the things that pass through our brains don't need to be remembered any longer than they need to be thought about. So that's another way of sort of thinking about things. Most of the time, vast majority of situations, you're using information for just a brief period of time and you don't need to hold on to it. So our system is sort of set up to sort of sift through this. It's really adaptive, right? Imagine if you remembered every trip to the store, or every phone number, or every trivial thing that you would have come encountered with, right? Most of the time, this stuff is no longer relevant, and in fact, what you need to know is new and different. So we forget in order to react to the present, predict for the future, which is more important, and forgetting the small details. This is a point we made earlier when we were talking about autobiographical memory, right? But forgetting the small details helps us extract the gist, right? The general meaning, and notice larger patterns, right? See the forest, create abstractions, right? This is something you came across in the Moonwalking with Einstein book as well, right? In order to be able to do that, you need to be able to forget the tiny little details. So while forgetting is mostly frustrating, it's also really important to everything we do. So the next question I want to pose to you is, do we always forget? And the answer is no, and this is best illustrated by a study by Erdelyje and Kleinbard. And what they did is they presented a list of 60 object line drawings, so like a drawing of a dog, a cat, tree, things like that. They presented them just once for study, and then they tested their recall over 20 times over the following week. And you see their data sort of graphed here. Now this is the cumulative number of items recalled, and as you can see, think about that Ebbinghaus forgetting curve. At the first retention interval, they forgot most of the items that they were shown, but they remembered a few more with each repeated attempt. So this is sort of the opposite of amnesia, right? So they called it hypermnesia, right? Because you're remembering more with each individual attempt, right? So additional attempts may help recall information that is not immediately accessible. This is a good technique to use if you're trying to remember something. Just say to yourself, I'll remember in a minute, or you can even say it out loud for that matter. I'll remember it in a minute. And usually if you give yourself some time, start thinking about something else, it usually comes to you within a few minutes. But if you think long and hard, it may never help you if you don't really use a good strategy. Let me give you an example. So let's say you lose your car keys, and you know the old wives' tale, right? Retrace your steps to figure out where you put your car keys. So a bad strategy would be if you lose your car keys and you keep going back to the same spot. That would be repeating a failing strategy, right? They're not there. So you need to go to different spots, right? So retracing your steps is a good strategy in that case to try to find your keys. And you're maybe not as familiar with memory search strategies, maybe something like losing your car keys you are. So let's talk a little bit about memory searching. So I could ask you, what's your name? And that's going to come up automatically because it's so well learned, right? You know what your name, you don't really have to think hard about that. But what if I were to ask you, what's the capital of Australia? Now you might immediately think of Sydney, but you'd reject that and say, no, it's Canberra, it's not Sydney. If I were to ask you where you were last Tuesday morning, you might have to think about your schedule, right? You might not immediately remember that, but maybe you could piece it together based on your typical patterns. We could search things for even our visual spatial information, right? How many rooms are in your home or apartment? We kind of talked about this back when we were talking about visual spatial sketchpad. And you could visualize and walk through your house or apartment. That's a strategy, right? Counting the number of rooms or windows or whatever in your house or apartment. What if I were to ask you what was Beethoven's phone number? Well, you would recognize, you'd have some semantic knowledge, and you would know that phones came after Beethoven, so he didn't have a phone, right? So that's a point where our semantic memory, our knowledge, can help us understand or know, like a meta memory kind of concept, that we're not going to have that information in our memory, right? So we should use some sort of systematic search strategy, but we don't normally do this. Why do you think we don't normally do a search strategy? Well, typically I think people are either lazy, they don't want to go through the time to search for the memory. A lot of times it's trivial information. Maybe they're using a search strategy, but it's sort of inefficient. Or maybe they don't know how to use their memory in this way. They've never really thought about a systematic search strategy to find information that's not immediately accessible. So another example of search strategies comes from this Williams and Holland study. And they wanted to know, they were interested in wanting to know what strategies people use to search their memory. So subjects were instructed to recall, in this study, subjects were instructed to recall each person they went to high school with. So imagine being asked that. Give us all of the names of everyone you went to high school with. Unless you went to a really small high school, this might be a difficult thing. And they did so over long time periods. So you see the increase in time, right? This is the hypermnesia, right, concept, where they're getting more information out with repeated attempts. Now, what's important here is they Williams and Holland looked at not just hypermnesia, but also how did they go about searching for the names of the people they went to high school with. So what strategy would you use? This is usually where I ask, and most people think, all right, well, I would come up with a context and then search that context, right? So I would think about the clubs that I was in, or the classes that I had, or the social circles that I traveled in, and I would think about all of the people and come up with individual names. And yeah, generally you do that, and generally you think of a new club or a new person, and then that leads to more names and so on. That's a strategy, right? Searching the context to come up with cues to remember those people's names. Now, one other thing I want to point out in this particular study, if you notice, they're coming up with some fabrications, and these fabrications increased as well over time with these search strategies. So we have to be mindful of the fact that, yeah, they're getting more correct names, but they're also making more errors here. So that's something we're going to talk about in our next lecture when we talk about distortions of memory. So we want to use good search strategies that lead us to accurate information and don't necessarily create distortions of memory too. So that's an important lesson to keep in mind here. So let's talk a little bit about why retrieval fails. So when we forget, why has this happened? And we can sort of break this down into a few simple reasons. So the first reason is it was never encoded. And what I mean by never encoded here, think about our discussion about attention. If you're never attending to the information, if you're never really processing the information deeply, you're not going to remember it, right? So remember the penny example when we were drawing a penny in class. Really hard to do because you've never really studied the penny, for example. We could also further this a little bit, and even in the encoded, and sort of say like the information was, maybe it was encoded, but it was never consolidated or put into long-term memory, right? Remember the name at a cocktail party or the Brown-Peterson task? Maybe you have that name in your working memory. You even say it back, so you encoded it, but it never got moved or consolidated into your long-term memory. So that's why I could, and this probably describes a large number of cases of why our retrieval fails, is we never really did what we needed to do to move it into long-term memory. But let's assume that we do have memories that we moved to long-term memory. We could still have failure of retrieval. We could still have forgetting. And why is that? Well, maybe we're lacking the right retrieval cue. So, right, remember we saw this when we talked about context effects on memory. So think like Godden and Badley's study with the people learning lists on land or underwater, or the clothes washing passage, right, with schema and things like that, or transfer appropriate processing. So if you don't have the right retrieval cue, maybe that's why your memory is failing. So also think like on an exam, if you don't have the information at hand, look at the exam for retrieval cues and maybe it comes back. So that's a reason why, is you just don't have the right cue. Another reason is memories seem to fade over time. So this is what we would call decay. So just a natural loss of detail over time. That's decay. And remember our discussions about autobiographical memory, where we remember the core details but we lose individual details. Or think about Ebbinghaus that we talked about earlier in this lecture, where you're losing a lot of information very early in a short interval. That information is just sort of disappearing due to more of a passive loss of information, right? This is decay. Now, if you can stave off decay if you keep thinking about things, if you reactivate those things, but also remember it could lead to some distortions. So those are some reasons, and we've talked about all of those at some point in time. However, one thing we haven't talked about is interference. And so sometimes our memories other memories actually interfere with our ability to remember, particularly if they're similar. So there's two types of interference here. And what I'm going to ask you to do is maybe pause this recording, get out a little piece of paper. Hopefully you're taking notes anyway. but write some things down so to keep these two separate. So the first is retroactive interference, and here's the definition. Later learning interferes with retrieval of previously learned material. So the way you could test this in the laboratory, and here's what you write down, is you have your first group. So your first group learns a list. You can write down list 1. And then there's some time interval, and then they learn a second list. Call that list 2. And then the instructions are to recall list 1. And you're going to compare their performance with a second group. So right on the next line down, write the second group here. And they learn list 1 also. But instead of learning list 2, they just have a rest period for some period of time. And then their instructions also are to recall list 1. Now, group B, or the second group, group B's recall is going to be greater than the first group, group A. Because, so go up to your first group and circle list 2, because that list 2 interferes, so some of those items may be falsely recalled, interferes with the recall of list 1. So if you circle list 2 in that first group, draw an arrow back to list 1, that's why it's retroactive interference, right? List 2 is interfering with list 1, which it was encountered first, right? So this is a real-world example, and I'm going to give you another real-world example here in just a second after I talk about proactive memory. But like if you go to a bank and someone, or you're filling out a job application, and someone asks for you for your previous address, or your employer, your previous employer, maybe your current employer, your current address interferes with your ability to remember your previous address or employer. Now, proactive interference rather, is when earlier learning interferes with retrieval of later learned information. So this is the other direction that information can go. So write down again, your first group, learn list 1, and then there's a delay and you're going to learn list 2, but now the instructions are to recall list 2. So write that down. And in your second group, right below that first group, you can call this group B, you can call the first one group A. They have a rest period instead of learning list 1. They learn list 2, and again, their instructions are to recall list 2. Now again, group B is going to recall, or your second group, is going to recall more than group A or the first group, right? But now what's happening, if you go up to the first group and you circle list 1, that list learning interferes with learning or recalling list 2 material. So you circle list 1, draw an arrow pointing to list 2, and you're going to see that goes forward in time, right? That's proactive interference. I think that's easier to find examples of proactive interference, quite honestly, because there's a lot of things that you learn early and then are no longer relevant, and now you have to learn some new information. So I'll give you an example that I had in graduate school. So we had a professor who taught us neural pathways. So you have to learn all of the structures of the brain and how they're connected. And Dr. Bunnell told us one of these neural pathways, and we learned it. Now, we learned it the wrong way because he told us the wrong way. And we know this because both I and my friend had the pathway written down incorrectly in our notes. So we both had the wrong information in our notes. But we learned it for the test. We both got that portion of the test horribly wrong. And we went back and looked at other sources for that pathway and realized that we had learned the wrong way. So we had to learn it correctly again for the final exam, so that was really hard. It was much harder than if we had just started with the correct pathway to begin with, because we had that earlier learning was interfering with our ability to learn the correct pathway. So not good, right? Also, this is think about it, proactive interference. This is a problem with discovery learning. So when you're reading the Willingham articles, he talks about discovery learning. So this is where you would have children engage in some activity to discover an outcome. And that's great, but you got to control what they discover, because if they discover the wrong information, guess what? You've just created proactive interference. So you really have to be careful and control those tasks so that there's really only one outcome, and that outcome is a successful discovery. Otherwise, that discovery learning won't be very effective at all. It actually create interference, and that's not good. So let me give you a couple of other examples, because I know this can be hard to learn, of retroactive and proactive interference. So retroactive interference, again, later learning interferes with previous learned material. So this is another real-world example. So our address when we first moved here to the college, or to New Jersey, and the college in New Jersey, was 2 Campus Court. 2 Campus Court doesn't exist anymore. It was bulldozed, and Campus Town is now over top of it, but that's what it looked like. It was this nice ranch home. And now this is our current house, 9 Cornwall, and actually the tree is actually blooming right now because it's springtime. But if I were to sort of ask, if somebody were to ask me, hey, what's your previous address? Immediately my current address would come up. 9 Cornwall, we've been here for a long time. So I would immediately think of that address, and I would be like, oh, I don't really remember what my previous address was. I know it was over near the college, right? But coming up with 2 Campus Court, that was the actual address. But in this case, my current address is interfering with my ability to remember my previous address, right? Retroactive interference. Now, an example of proactive interference, again, earlier learning interferes with later learned material. I have another example for you. I told you this is easy to come up with examples of proactive. So this is a campus map of the University of Georgia, and you can see right over here, N09 is the psychology building. That's the psychology building, University of Georgia campus. And when I first started graduate school for many, many years, graduate students could park right across the street in this nice lot that I have circled over here in yellow. And it was great. You would get there, you could just walk right across the street to the psychology building. This red parking lot is for faculty, right? But we could park right over here. Well, eventually the campus continued to grow, as all campuses do. And they decided to take away our graduate parking lot, and they decided to move us over here by the mill. This was the closest lot now. So we had to park in a new place. Well, I had parked in this lot for many, many years. So for several days, or many, many days, actually months, I would drive mistakenly to this parking lot first before I realized, oh, right, I can't park here anymore. And I would have to go down the street and park by the second mill, right? So each day I kept coming to that first parking lot. It was really hard to learn to go to directly to the second parking lot because of this proactive interference, right? So that whatever I learned first was interfering with my ability to now learn to park in a new place, right? So that's it for forgetting. Our next lecture is going to be distortions of memory.